In this lesson, we're going to examine a specific class of chemical compounds. If you study chemistry for perhaps in college or in a different course, you'll find that you will study several different classes of compounds, like organic compounds, maybe alcohols, esters, ketones, things like that. Today we're going to focus on one specific type of compound, and those are called acids. Now, when we think of acids, we think of things that are very caustic, things that will burn you, things that are dangerous. But honestly, acids are very common, and they're found in your body. For example, hydrochloric acid, very dilute hydrochloric acid, is found inside your stomach. Also, when you eat an orange or you drink most juices, you're probably taking in vitamin C, which is an acid. It's called ascorbic acid. Also, in your cells, you have DNA. That's the A stands for acid, deoxyribonucleic acid. And so there are acids pretty much everywhere in your body, and they're very important for life. Well, let's take a look at the formulas for 3 acids, and we'll try to see what they all have in common. Now, hopefully, you can see that these 3 acids, as do all acids, have hydrogen in them. And so the most basic definition of an acid is any compound that produces hydrogen whenever it's dissolved in water. And so pretty much the easiest way to recognize an acid is to look for the hydrogen, the H, at the beginning of the formula. So notice what these 3 acids have in common. They all have the H at the beginning, the hydrogen, and we're going to name these acids. The way to name these is, first of all, to ignore the hydrogen and just look at the rest of the compound. Look at the anion part of it. And so in the last lecture, we learned about naming ionic compounds, and we said we had to split these in half. Well, that's basically what you have to do here. Split these in half. And you'll find that when you name the anion part of those acids, here's what you get. With the Cl, it's chloride. The F is called fluoride, and the Cn is called cyanide. So what you do here is we take off the IDE ending, we just take off that suffix, and so we have the root. We have chlor, take off the ide here, we have fluor, we took off the ide there, and we have cyan. And what we do is we put hydro on the beginning of the root and ic at the end, like this. So HCl is called hydrochloric acid. HF is called hydrofluoric acid. And HCN is called hydrocyanic acid. Now let's take a look at another set of 3 acids, and you'll find that these acids also have hydrogen in them, but they have something different. Do you notice something that these acids have that's different from the last 3 acids? Well, I hope you notice that they all have oxygen at the end of them, and they do. These are called oxyacids. Any acid that has hydrogen in it like that is called an oxyacid. But once again, to name these, we basically do it the same way. We split it in half, and we name the anion. So the NO3 is called nitrate. ClO3 is called chlorate. And PO4, with the 3 negative, is called phosphate. So notice that the suffix is different this time. It's not IDE, it's ATE. So we're going to name these differently. We're going to take off the ATE suffix, the 8, and we're going to replace it with something else. So we now have the root, we have niter, chlor, and phosp, and so we're going to replace the 8 with ic. And so HNO3 is called nitric acid, and HClO3 is chloric acid. H3PO4 is called phosphoric acid. Now notice that the name is a little bit different. You might think it would be phosphic acid, but someone at some point, I suppose, decided that that would sound funny, so they put put that extra syllable on there, the or, so it's phosphoric acid. Very common and important acids. Phosphoric acid, for example, is found as an ingredient in Coca-Cola. You can also use it, Coca-Cola, to clean the corrosion off of a car battery if you need to. Let's take a look at another set of 3 acids, and I want you to notice that these 3 are oxyacids as well, but they're different from the last 3 that you saw on the screen. And this is tough. Can you tell how these 3 oxyacids are different from the last 3? Well, if we split these in half and name the anion, the NO2, the ClO, and the SO3 2 negative, they don't end with 8. They end with ite. And so NO2 is called nitrite, and ClO negative is hypochlorite, and SO3 2 negative is sulfite. And so this time, we take off the suffix, and this time the suffix is ite instead of 8, or ide. And so we have the root once again. We have niter, hypochlor, and sulf. And this time, we add a different suffix. We replace ite with us, O-U-S. And so HNO2 is called nitrous acid. And HClO is called hypochlorous acid. And H2SO3 is called sulfurous acid. Notice once again, it's not sulfus acid. Somebody at some point decided that sulfus acid would sound funny, so they put that extra couple of syllables or a couple of letters on there, sulfurous acid. You'll find that that happens anytime that there's a phosphorus containing acid or a sulfur containing acid. It's going to have that extra couple letters on there. So this is how you name acids that have anions ending with ite. So let's summarize this. We basically can say we have 3 classes of acids. And so if the ion name or the anion name ends with IDE, we replace it with ic at the ending, and we also stick a hydro at the front of it. If the anion ends with 8, it gets changed to ic. And if the anion ends with ite, it gets changed to us, O-U-S. So let's do a few examples together and see if you understand the process. So here's the first acid we're going to name, HC2H3O2. So once again, we have to split this in half, and we name the anion part of that. So if you look at your ion chart, or if you've learned this already, you know that C2H3O2 with a negative charge is called acetate. And so you can look at your ion chart and see that. So 8 gets changed to what? Well, we take off the 8, and 8 gets changed to us. Gets changed to ic. I misspoke. So it gets changed to ic, I-C. So it's acetic acid. So acetic acid is the scientific name for vinegar. So you've probably heard of or even used vinegar, maybe used that for cooking or cleaning or to put on a sandwich or something like that. So that's vinegar, acetic acid. So the 8 gets changed to ic. Let's try another one here. We have HNO2, and so once again we have to split this in half, and we name the NO2, and so that anion is called nitrite. And so the rule says that ite gets changed to what? It gets changed to us. I was ahead of myself on the last one there. This one gets changed to us, O-U-S. So we take off the ite and put us on that one. So this is called nitrous acid. And let's try one more, except this time we have a name, and we have to write the formula for that. Oxalic acid. Well, we learned that the ic suffix implies that the anion ended with 8. And so we basically have to name this, or rather write the formula, as if it were an ionic compound. So acid implies that the cation is H, and then ic, we said that's oxalate. Oxalate is C2O4 with a -2 charge. Hydrogen, of course, is a +1. So like we did in an earlier lecture, do we look at those charges? Do they cancel out, or do we have to swap them? Well, since the absolute values aren't equal, we have to swap them, so the 2 goes down here. And oxalic acid is H2C2O4. And so here, this is just a brief tutorial on how to name acids.